So hello there, welcome to the part 2 of the AES QR code scan using the Raspberry Pi camera and an Android app. So last part 1 we developed an Android app to generate an AES encrypted uh, QR code data, and we want that it is our Raspberry Pi that can decrypt the data for a certain use in your project, or maybe you want this an application that requires QR code security, and there's an encryption decryption that is happening. So now we hop on again to our Raspberry Pi to develop a QR code scan and decryption algorithm for our QR codes. So before we begin, you gotta make sure that you have properly interfaced your camera module in your Raspberry Pi. So whether you're using a USB webcam or a dedicated, uh, a compatible Raspberry Pi camera module, you gotta configure it first. So if you don't know, sudo raspi dot slash config is I guess the command. Yeah, so you have to enable it first in the interface options and the camera. So I've already enabled it, so let's just go back. And other things to be done beforehand is installing some dependencies or package. So as you might already know, we'll be using OpenCV Python API to scan or detect QR codes, and we also have some dependencies like the NumPy for implementing mathematical operations for certain arrays upon scanning a QR code. So I'll explain those later, and the PyZ bar to decode detected QR codes. So again, install these three first. So if you haven't installed it, go just search OpenCV Python and go on to the PyP or whatever you call it um, website, and it should have a command for the pip installation for this one. So just copy on it and paste. However, if you haven't configured properly the command for the pip, you might be using an obsolete version. So I prefer to use the pip 3 because I forgot if I have configured it properly, that whenever I enter pip, it will automatically do the pip 3. But anyways, let's just enter this. Um, if I remember correctly, I've already installed this one. So, oh yeah, there's an update, I guess. So let's wait for a while. Okay, so another thing is the NumPy. I think it's the same command. You just replace the package name or dependency name that you want to install. Just pip install. No. So yeah, it's just the same. Install NumPy. Just paste it on your command console. And the same for the PyZ bar. So go on, check on their documentation if you want more details about it. So anyways, as you can also see, I have already my code finished right here just to save some time. And yeah, it's pretty much straightforward. It's just it's actually just a 20 line code. So first things first is you need to declare or initialize your video source, your camera source. So what was I? So again, you want in this line, you want to specify the camera source. So in my case, I only just use one camera component or device interface in my Raspberry Pi. So that has a default index of 0. So I think yeah, if you have no webcam or yeah, other camera interface in your Raspberry Pi, so I think 0. Just try this one index first, and there's actually a index dedicated for like automatically detecting a camera that is interfacing your Raspberry Pi. So it's -1, but I've already tested this one, so it is at index 0. And so that's it for the video capture. So yeah, cv2 that video capture, and you assign it to a variable because this will return, I guess, a yeah. Then uh, the next here is to set some uh, this part right here is basically setting up a window to display the camera capture, camera video capture. So 3 is the index for the, I guess, length. I forgot. Yeah, yeah, length, and is yeah, it's just a basic resolution of 64 by 48 for ATP. 4 is for the width. So you need to set up the dimension of your window. And next is the while loop right here. So if you don't know about the basics of the OpenCV, in capturing a video, it's actually taking frame by frame. So what we are doing here in the while loop is that okay, let's first discuss this line 11. So we pass on two variables because this cap that read is actually let's say capturing a frame in your camera, and it will return a boolean variable if success, if the frame is captured properly or not, and it will return that specific frame here, this variable frame. So doing this in while loop is yeah, capturing frame by frame, and displaying it in the window will actually look like a yeah, a video stream. So which is why we can like implement some OpenCV functions on a video because we implemented it frame by frame, if that makes sense. So now here in a for loop, we have a for each loop here, a decode frame. So again, we captured that specific frame at that particular time, then we decode it. So basically what is done here is um, it decodes a QR data, QR code or even barcodes. It extracts a specific, it extracts the data on it. So this basically does the job for us, this single function right here. So it decodes it decodes or extract the data that is in the frame if there's a QR code in that specific frame, and uh, it will assign it to an object or a QR code here, variable right here. So why, you might ask why it is in the for loop? Because there might be instances wherein in that specific frame there are multiple QR codes placed in that frame. There might be two, there might be three. So the decode OpenCV, yeah, the PyZ bar actually can cater multiple QR codes in a single frame, and yeah, it will return a list. So each list will we will assign it to a yeah, we will cater that those specific each list and assign it to an object. So here we decode, we the QR code actually returns a map wherein you can extract the data, the polygon coordinates, the rectangle coordinates. Uh, yeah, better explore that first in the OpenCV documentation. Um, so yeah, that's basically it. What we are interested first right here is the data. So it will get the data, and again, the data is in binary format. So we want to decode it into string. So pass in the Unicode format right here, decode UTF-8, and assign it to data, and print. Let's print every data that we have extracted uh, in every single frame. And so yeah, if as you can see here, there are some comments that I will explain right after I show or after I run this one. So yeah, after this one, after extracting and printing the QR code data, we will show it in a window. So image show, then this is the title of the window and the specific frame that we want to show, and the wait key. And so this is basically such a delay, 1 milliseconds. That is important so that yeah, it's just a basic practice or to do this one. So let's first run this one to see if it really decodes a QR code data. But as you might have known, in a text editor like Visual Studio Code, it can't show any visual interface in an SSH. So as you might have already downloaded or already know, there's a specific um, application for that, the VNC. So it's the same as yeah, it's basically also an SSH communication. It's just that we can see the graphical user interface of that specific system, such as the Raspberry Pi. We know that the Raspberry Pi has the Raspbian OS that will has an user interface for us. And yeah, just enter the same IP address or of that Raspberry Pi, and the Raspberry Pi has like a shortcut for it or the identifier of that specific address. So double click on that one and here. So I've stored my that code that we have just programmed in the VS Code in my documents. Just double click that one and it'll automatically launch the Thony IDE. So let's just quick run and let's see if it really decodes some data. Oops. I'm having a trouble here, error right here. So let me just pause. So I just discovered that the exception that happened to me is actually my NumPy library is outdated in a sense. So if you're having or facing the same issue with mine, uh, there's enter pip3 install NumPy and double dash upgrade to upgrade it to its latest version. So as you can see, I've already upgraded mine. So yeah, it's been a while since I've installed this NumPy, and um, yeah. So go on back to your VNC viewer and let's run this code. So here, as you can see, is the camera display, and I'm just trying to open the app that we've developed in my device, and let's enter the data test. Uh, it should uh, read from our Raspberry Pi or scan the QR code and then encrypt the data. So Let me just first, I don't know if you can see it here. As you can see in the um, output shell, there there's some output data that's sprouted here. So this is right here is the um, encrypted text of the data. So that might be good on, you know, that might be enough for you, but let's implement some object detection, actually, like in displaying or the text or the encrypted the scanned text of the QR code, and also like identifying the QR code or containing it into a square. You might have already seen this in OpenCV applications where there's a the QR code is contained in a rectangle line or a polygon line, if you might say, and there's an QR code or the QR code data above it. So let's do that. This is the actually the one right here that I have uh, in comment. It's really hard to uncomment or comment multiple lines in the Thony IDE, so that's why I really prefer uh, SSH communication using Visual Studio Code. So control forward slash backslash, man, I don't know. So yeah, this is the lines. So there are a couple of things to note here. First, I have a variable called CD, which stands for coordinates. So the numpy, let's call the numpy um, library, then call the array method. So basically what it's doing right here is the QR code, the polygon that we have extracted during the decoding the specific frame returns several coordinates of a polygon for that specific QR code in that specific frame, and we just want to store it in an array in a integer 32-bit data type. So because we want that to uh, in our reshaping and um, in establishing the polylines in our window frame. So yeah, just do this, reshape it, and here we will draw the polylines. The reason why we use the polylines is that because instead of rectangle lines, is because it won't reorient whenever the QR code is in somewhat not in a rectangular position. Like if you might rotate your device or your phone in a 90 degree, I mean a 45 degrees, it won't display the polylines. I mean the the lines in the window. So which is why polylines is much preferred. So there are a couple of datas that we want to pass in the polylines: the frame, the specific frame right here, and the coordinates array that we have extracted right here, and the true if it is we want the polylines to be closed, not in a not just the coordinates itself, but to really close the shape. And the color, we want it, yeah, this is in RGB. It's actually RGB. It's actually in a reversed, I don't know why they reversed format it, but we want a green color for the lines and a thickness of 3. So we're done with the polylines, but you want also to display the text above the QR code. In order to do that, we extract the rectangular mapping points of it, of the specific QR code. Is because if we pass in the polygon, uh, the QR code data would also reorient whenever you uh, like uh, have an whenever you have an angle in your QR code data. If you like again, position your device in a 45 degrees. So we are just basically catering all different instances of the position of your QR code. So we want the rectangular coordinates of it, because we want that whenever, even if the QR code data is uh, not in a let's say in a perpendicular position, we want that it's directly above, not it's not like oriented the same to the orientation of the QR code. So if what I've said is doesn't make sense, uh, it's just better to show you the output of it later on. So just bear in mind with the like specifics on it. So yeah, this is the put text. We want to put text the decoded data. So we place it here, the data. So we couple of things that we have to pass in the parameters, the frame, the data. Again, this is the decoded already in string format or Unicode format, and the points of the rectangular, because again, it is only the top part that we want to show the data, the QR code data. So it's only the 0, 1, not the bottom part, the 3 and 4. So, and the font type of the data we want to display, and the scale of it, 0.9, and scale or like font size as well. This is the color of the text. We want with the same color with the polylines, color green, and the thickness of 2. So let's test that out. Again, we just want the coding be done here in the Visual Studio Code, but the QR code display is done in the VNC viewer. So let's, let's actually um, reopen that one. So it's here. Let's click run. So let me just open my app again, and let's enter the data test. So it should have an encrypted text, the same that we have that outputs the um, later. So there, shows the QR code, and this is what I mean with the whenever you have a certain angle, it always shows the data above it, not going above with the polylines, like directly above it. So it's actually good, even though my the contrast of my device is not that good, or the brightness. And as you might have already see, there's some glares in my device. This is actually an issue whenever you have a camera based application in your Raspberry Pi. So this is the encrypted text. Again, this text doesn't make sense at first because we haven't done the decryption, the AES decryption. So now that is done, let's do the decryption, AES decryption algorithm. So let me try this different datas, like alphanumeric, because that's what we want to put in our data. So here, again, it's just different data. So let's do the decryption. Now we are back at the Visual Studio Code. Let's begin on doing the AES decryption algorithm. So there are a couple of things again, mainly for AES encryption decryption. We basically do the job on an existing open source packages. The same thing with the Flutter, with the Android app that we developed. Uh, the Python is no exception. There are a lot of open source packages or dependencies that we can use. And for the AES decryption, there's fortunately, there's a cryptography library that we can use. It is called the PyCryptodome. So, yeah, PyCryptodome again, as stated in its description, it is a package for low-level cryptographic primitives, which include AES. So go ahead, install this one first, and also check out to its documentation. It has a, wonderful documentation, which is really good, and most especially the mode that we are using. Again, we use the AES.CBC mode in our Android app. So we will do the same for the Python decryption. So here is the CBC mode. So essentially, this mode again, it explained here that it is stands for ciphertext blockchaining. Again, its algorithm is more on um, the code blocking, and it states here that the plain text block gets XORed with the previous ciphertext block prior to the encryption. So if you want to go deeper with that, just check onto their documentation. So install the package to your environment, and as you can see, I've already have some commented changes here for the AS decryption. Uh, because yeah, just to save time, and I'm really slow at typing. If to be honest, so let's uncomment this one. So I think this base 64 is a primitive, or I guess it comes with the Cryptodome package. So yeah, from the base 64 module or package, just we want to use the base 64 decode. I'll explain it later. Just do these things first. And of course, the cryptography mode we use the AES imported from the crypto.cipher, and the utility padding. We want to use the unpad one. Yeah, I think we don't need the pad. Yeah, just unpad. And yeah, just import these essential packages, and let's get head on to the code. Again, this is just the same as before for the QR code scan, added in between the decryption algorithm. Yeah, to be let's just um yes, decryption. So let's just comment that out so that we can identify right away. And let's uncomment this one. So let's go this block of code line by line. So there are a couple of things that I haven't really mentioned during now uh, last part, the first part where we built the app in terms of the specifics of the AES encryption. So I'll explain that later. So if you have remembered in the while we developed the app, um, we encoded the output of the encryption of the Flutter to a base. We encode it into base 64, mainly to to have data, even though if it is it is in a space and such, and just to really yeah, actually you don't need to encode or decode it into base 64. It's just a matter of preference, and it also adds, I guess, a security. So yeah, you can opt to do it or scrap this out. So again, if you followed my program in the first part when we developed the app, I encoded the output of encrypted data to a base 64. So once that is scanned in our QR code scanner algorithm right here using the OpenCV, it was again store the data in the variable data, and we want to decode it using the base64 decode method, and store it into CT, or uh, stands for ciphertext. You can name it anything you want, and CT. Then yeah, I guess that is pretty much understandable in this line. So in this line, let me in this line, we create an instance of the AES algorithm. So dot new, and remember the key. This is actually the key parameter. So remember, when we develop the app, we just we just entered 32 once for our key, and again encode it into UTF-8. And for the IV right here, third parameter of this function, I mean this constructor, is 16 IV, 16 once for the IV or initialization vector. And yeah, those are the parameters, the key. And I forgot this one is the mode, the specific mode. We will be using the CBC because that's what we use in the Android app as well. And the third one is the initialization vector. So yeah, we just create an instance of it and store it and declare it into the cipher. And this is what I forgot to mention during the when we developed the app. Actually, let's go on to the documentation of the app. So this was the package that we have installed in the pubspec.yaml, and um, by default, the AES.CBC, yeah, again we use the AES algorithm, and its default. I mean, we explicitly state that we'll be using the AES.CBC mode, if you remember, and by default, the padding is enabled, and if you didn't specify it, so it was enabled by default. And uh, yeah, since we didn't pass the padding equals nulls, again we didn't put this. So uh, the encrypted text was actually padded. I don't know much of the specifics of the padding. It's just that the output of the encryption and AES-CBC encryption, um, ha, they it has a specified length, and example 16, I guess. I forgot, it was 16 character length is the preferred output length. But during the encryption, if it didn't uh, if it didn't like match to a 16 character length, it will just either be empty spaces or padded with by default in this one is like equal signs. So we'll see it later. Okay, so again, just remember that the padding for when we developed the app, it was enabled because we didn't pass in a specific parameter to null to it. So since the encrypted text was padded, we need to unpad it one here. Again, it's just a matter of formalities. You can opt to again in the app, you can opt to like pass the parameter null in the padding, but and we could just scrap out this unpad because again we didn't pad. But yeah, we did that one because I want it to have a um, exact character length and any other data that we want to input. So again, we'll see it later. I mean, you have again, yeah, in the the later past section, you see the encrypted text. There was like in its succeeding parts, there was the an equal sign. That was the padded character. So yeah, this is the unpad method or function, and we pass in the decryption function. Again, the CT, the scanned QR code data, decode it in we decode it by base 64, and the AS dot block size, they are is AS block size as a default one. I just pass on the default one, the block size. um Again, you can opt to specify it. I Yeah, just make sure that you know what you're doing. And yeah, after unpadding that one, we again store it to data. Then we decode the data because the output of this one is again in binary, and we decode it. Yeah, you don't have to explicitly pass the parameter of UTF-8 because it is the default one. So yeah, so this is hopefully the data, the plain text data, the decrypted plain text data. So we'll see when we run this code. Control S, save this one, and let's head on to the VNC viewer. Let's close this because so that the changes will reflect. Open it again, and let's hit run. Hopefully no errors. So okay, let me just launch my app. So the data that I will enter right here is test. So again, what we should expect is we should see in the in this window a text above the QR code, and uh, okay, my OpenCV is a bit laggy. So we should expect the decrypted data, not the encrypted data. So let me generate my code, and here, there. So I inputted test data, and as you can see here in the command console is the encrypted data. And as you can see, the succeeding characters in this encrypted data is the equal signs. This is actually the padded character. So yeah, this is um, the decrypted data showing in our window. So again, the purpose of why am I doing this is that you want to have a QR code, an application, I guess, in your project, and you want that it is only your project that can extract the data, uh, so that QR codes nowadays is easily can be easily generated using an app, and uh, you can also scan the QR code, and in that way, maybe hackers or unauthorized persons can easily replicate the data that you are using in your system, I guess. So adding some security like the AES encryption and decryption uh, can mitigate that problem, to really add more security on your project. Because I guess again, I'm working on a project wherein just it is just the QR code is basically the QR code is the key of the project. Some kind of again, you might have noticed in my previous video where I work on a parcel locker using Raspberry Pi, and it will only I mean the recipient or the user can only open such compartment door using a QR code. And maybe there are other people, maybe malicious people can easily replicate your data, then generate into QR code and can access that compartment door. We don't want that. And yeah, hackers nowadays are quite intelligent, and they can uh, maybe predict the algorithm that you are displaying as data in your QR code. So yeah, AES encryption is, I mean, any encryption cryptography is quite important nowadays, especially now that QR code is now, uh, uh, it's like a norm nowadays in um, accessing some links, websites. So yeah, I hope you um, learned something on this video, and hopefully you can implement this in your project if you have a similar use case project like with mine. So thank you for watching.